Okay, so this is going to be our final temperatures lecture for this unit. What we're going to do here is we're going to kind of tie some of the pieces together and talk about some applications. Here's what you need to do. Just listen. You're going to make a summary. We will make a summary at the end of this video before you take the notes check. So you need to listen carefully and do this quickly because we do have a notes check for the second half of class. So looking at our lab activity from last week, we had the white and the black sand. We understand that one of them has a high albedo, one has a low albedo, one soaks up more sunlight, one reflects more sunlight. You can do the same activity outside where we have some black and some white squares painted on the concrete, and you can see there's an actual real difference in the temperature between the white and the black concrete outside in the sun. But this also was done. We had some green artificial turf, and it's a nice dark green color, and then we took the temperature of a nice dark green plant. They're both dark green, both dark colors, should have a fairly low albedo and soak up a lot of sunlight. However, what you notice here is that the artificial turf has a temperature of 107 and the about same darkness or color of a plant is only about 80. So now there's something else that we have to consider when we look at these temperatures. And that is the effects of plants, or how plants have a temperature. First of all, let's go back to this from biology, photosynthesis. You know what this is. You know that plants take sunlight and they use sunlight to make food. But I want you to think about sunlight or energy as a dollar. Remember, it cannot be created or destroyed. Think of you have $1 worth of energy, or let's say you have $1 worth of money. Well, you can save that money if you wanted to, put it in the bank, or you could go out and you could spend that money, but you can't do both with the same dollar. You can't save $1 and spend it. You could save half the dollar and spend the other half, but money can only be used once for one thing. Well, think of energy is the same way. You can only use energy from the sun pretty much one of two ways. You can soak up sunlight from the energy, and that's going to make your particles move faster, cause more friction. It's going to raise your temperature. But in the case of plants soak up sunlight and they use that energy from the sun to make food through the process of photosynthesis. So if a plant is doing this with sunlight, it cannot do this. This means that plants tend to stay fairly cool even in the brightest of sunlight. If you go outside on a hot sunny day, middle of the summer, touch a leaf, it's not going to feel particularly hot because the sunlight that is being absorbed by the plant is not being used to make the particles move faster. It's being used to make food through photosynthesis. Now, a parking lot, all the sunlight that hits the parking lot, it is not being used for photosynthesis, which basically just makes the particles of the parking lot move faster, have more friction, and when parking lots get hot, they have a high temperature because they're just soaking up all that energy and using it to raise temperature. On the other hand, all of the sunlight that hits the plants and the trees in this photograph, most of that, the majority of all that sunlight is not being used to raise temperature. That means if you have plants, you tend to have somewhat lower temperatures because so much more of the sunlight is being used for photosynthesis.
So here I am at the former Super Target on Holcomb Bridge Road. And you may not know this, but up until not too many years ago, this entire area was a forest. It was nothing but trees. Well, they came and they cut down all of the trees and they paved this parking lot and they built the building back there. So what does that have to do with temperatures? Well, on a nice sunny day like today, all of the sunlight hits the nice dark parking lot, hits the metal building, and all of that sunlight gets soaked up, which means the temperatures go pretty high. The temperature of this parking lot is about 120 degrees. Now, what would have been different had they left the forest here? Trees will soak up sunlight, but they use the sunlight for photosynthesis to make their food. Well, if the sun's energy is being used to make food or photosynthesize, that energy then cannot be used to make particles move faster, create more friction, and raise temperatures. So we know this, that plants help keep the temperatures cooler because the plants will use the sunlight for photosynthesis. This parking lot can't do that, so you build parking lots, you build buildings, and the temperatures go up. Roswell is now hotter than it was before they built this Super Target. So the more trees we cut down, and the more parking lots, and the more roads, and the more buildings we make, the hotter an area gets. That's a phenomenon known as the urban heat island, or the fact that cities are hotter than the countryside because we take away the plants and we replace them with materials that just get hot as they soak up the sunlight. So once again, this leads to the phenomena known as the urban heat island, or the fact that cities are hotter than the countryside because there are so many fewer plants to soak up the sunlight. Alright, so now I've gone just a few miles away from that previous location, and I'm on the Big Creek Greenway, which is a large area of undeveloped land here that runs from Forsyth County all the way through Roswell and Alpharetta. And as you can see behind me, there is no development here. There is no roads. They've left the trees and all of the plants in place. And when you take the temperature reading here, the temperature here is about 83 degrees. And that's because all of the sunlight is hitting those trees, it's hitting these plants. And the plants take that sunlight and soak it up through their leaves, and they use that energy to make their food through the process of photosynthesis. Well, a road and a parking lot can't do that. So when sunlight hits roads and parking lots, the temperature goes up. But if we leave plants and trees in place, it dramatically lowers the temperature of an area because the sunlight is used to make food for the plants and the trees, and therefore it cannot be used to make particles move faster, increase friction, and raise temperatures.
But actually, another way in which plants really help keep temperatures down, that's this process called transpiration. And you remember this from biology, hopefully, that plants take up water through the ground, they move them through the body of the plant, and they spit water out into the air through their leaves. Well, that means if you have a lot of plants, you wind up with a lot more water up in the air. And we know that water can't get hot nearly as quickly as a place that is dry. Parking lots, on the other hand, parking lots don't add any water to the air, so they don't do anything to help regulate temperatures and keep temperatures down. Here you can see a thermal image of a road, sidewalk, and grass. And you'll notice here the road is the hottest because the road is black asphalt. Sidewalk is a little bit cooler because it's a white concrete, and the grass is by far the coolest because the sunlight that's hitting the grass is being used for photosynthesis and therefore cannot raise the temperature of the surface. Now, here's what we do. We cut down all of the trees, and all of the sunlight that used to hit these trees is now just being soaked up by that ground, which means now so much more of the sun's energy is being used to raise temperature. So places that remove plants and trees tend to be hotter. Well, where are there less plants and trees? That's certainly in the cities. Take a situation like this, big urban center like New York City, there's no green there. And basically all of the sun that hits these buildings and roads and parking lots just makes them hotter. You can actually see that if we examine some temperatures. Well, here in Atlanta, and this is in October, average high of 72, and Roswell is 2 degrees cooler. And the difference can be explained not by latitude, not by elevation, not by water, but the fact is that there is a lot more plant cover in Roswell. So a lot more sunlight that hits Roswell is being soaked up by plants used for photosynthesis and therefore cannot be used to raise the temperature. This is what's known as the urban heat island effect, and it's a very simple concept. And this is the idea that temperatures in cities tend to be higher than the countryside around them because of the lack of trees. You can see this in some thermal imaging maps. Notice Boston, really, really hot right here where the city is, and yet you go out here, get outside of the city, if there's no plants and trees, it's a lot cooler. Here is France. Paris, France, as you can see, is very, very hot in the center where it is almost all buildings. And the further away you get from the city center, where you have more plants, trees, farms, it's going to be cooler. An interesting example of this is Minneapolis, Minnesota, where it snows in the wintertime. You can see here all of this snow out here, all that white stuff, that's all snow on the ground. But here, The city of Minneapolis is so much warmer that the snow doesn't stick on the ground because the snow melts. You can see this in a typical weather map that they'll show on the news or on the Weather Channel, where typically the city of Atlanta is going to be a few degrees warmer than the locations that are outside the city, and that's primarily due to the fact that there are fewer plants and trees in the city of Atlanta. So, to answer this question, the why, what's different about the suburbs versus the city that changes the temperatures? Is the plants. And we're going to look at Atlanta as a case study. We're going to see how has Atlanta changed in 30 years. In these next two pictures, green represents an area where there's at least 50% of the ground is covered by trees or plants. And red or black represents the urban surfaces, roads, parking lots, dense buildings. And you see here in Atlanta in 1973, well, here's downtown Atlanta. Here's the area near the airport. Here we're getting up here, Marietta. This is getting up in Gwinnett County. So this is 1973, and there's a lot of green covering the city of Atlanta. Well, now we've got Atlanta in 2003, and you'll notice there is a lot less green and a lot more urban surfaces. So with fewer plants and trees, we would expect the temperatures of Atlanta to have changed a lot in that time period. And here's another graphic. Now, it doesn't matter what the numbers are associated with here, but we've got this color shaded map and we get it. Okay, here temperatures are higher. And we got a little high point of temperatures right here near the airport because that's where there's a lot of roads, buildings, a lot of natural surfaces, and fewer plants. And if we fast forward to 2003, you'll notice these areas where the temperatures are higher have gotten bigger because the city has grown. We've cut down more of our trees and built more buildings and things that soak up sunlight, making the city hotter. Interesting picture here of New York City. If you'll notice, New York City, a lot of brown, a lot of high temperatures, a lot of urban heat. In fact, we've got this one little kind of square rectangle in the middle of the city. That's not water. We get why this is cool, because that's the rivers, and the rivers don't change temperature as much, and they're represented with that blue or cooler color. But in the center of New York City, we have Central Park. And Central Park is covered with much more plants and trees than the rest of the city. So it actually is a few degrees cooler on an average day than some of the cityscape around it. So why should you care? Why should you give a flip about the urban heat island? Well, it comes down to money. Because the hotter the city is, the more you have to run your air conditioner. And your air conditioner is the number one power drain in your house, especially in the summertime. And running your air conditioner is expensive. So the cooler we can keep cities and the less we have to run our air conditioners, the better off it is for all of us. So what can we do? What can we do to help minimize this urban heat island effect? Well, the first thing we can do is plant as many trees as possible. And in the city, that's hard because we've already built our roads and our buildings, and nobody's going to take out a Kroger and plant a bunch of trees or knock down a neighborhood and plant more grass. However, if you can work just a little bit of trees or plants into the environment, this can help a lot. Put some trees in our parking lots. And we do this sometimes. This parking lot is going to help keep temperatures much cooler than this parking lot. Because even though it's not covered with plants and trees, there are still plants and trees that are going to soak up some more of the sunlight and help lower the temperatures.
So we know that plants don't get hot because they use all the sunlight for photosynthesis to make food. Therefore, plants really help to keep places cool. And one of the things you can do in urban environments to help keep the temperatures down and reduce that urban heat island effect is to put plants on top of or around the sides of buildings. That's what you see what's going on here with this building. I'm in the middle of a big city in Japan. Lots of concrete, gets hot real easily, bright sunlight. But if you put plants on top of the building or beside the building, those plants are going to soak up some of the sunlight and help keep the temperatures a little bit cooler. This is what's known as a green roof, and it's not because it's painted green, it's because plants are green, and the green in the plants soaks up the sunlight for photosynthesis. So once again, a green roof is putting plants on buildings so they soak up more sunlight and help keep the temperatures down and reduce the urban heat island effect.
So some examples of that, just putting some grass on top of a flat roof building. This is in Singapore. In old days, they used to put sod on the roofs of houses, and they really act to help keep a home cooler, especially in the summertime, because the grass on the roof would soak up some of the sunlight. This is another one, Fukuoka, Japan. You can imagine all the sunlight that's soaked up by those plants. And in a city like Fukuoka, Japan, where there are a whole lot of green spaces, every little bit of a green roof helps. Edinburgh, Scotland. Like I said, this is a kind of a cutting edge thing a process that's being used around the world. In Hong Kong, it's a big deal in Hong Kong. They're trying to put plants on top of every place they can, and this is a newer building because this is pretty much what Hong Kong looks like. It's really crowded. A lot of buildings that just soak up sunlight and get hot. And it doesn't have to be big, huge, fancy trees and bushes. This is in Berlin. These are some almost mossy type plants. Anything that's green, any plant that is going to help soak up sunlight to photosynthesize is going to help to reduce temperatures. Same examples here. In New York City, it's an old city. They're trying to go back now and on little ledges of some of these old buildings, put in some plants to help reduce that urban heat island effect. Here we've got some examples in Seattle. Some more examples in South Korea from this past summer. And you can see, once again, the impact that these plants have. Here's the plant side, and you'll notice over here, it's a lot cooler. Here's an area, not only is it not have any plants on it, it's also a dark color. It's going to soak up a lot of sun. Notice how hot it is. So if we change the color or the materials that we use in a city, we can change that urban heat island effect. This was an experiment that was done not necessarily for the urban heat island effect, but for amount of light. And they experimented with some darker colored buildings. And they noticed it was kind of darker because the light would not bounce off the buildings and reflect and illuminate the area. It would just be soaked up by the other. Well, if they started painting buildings that were lighter colors, well, we know that lighter colors are going to reflect light. Well, if we translate that to the urban heat island effect, that means lighter and darker materials are going to have different temperatures. Here are two samples of building material, two samples of a marble. One was white, one was black, and you notice in the same sunlight, the one that's black is hotter. So if we build buildings out of light colored materials, it's going to help reduce the urban heat island effect. And Amman, Jordan, from this past summer, is called the White City because they specifically used limestone and marble, specifically, even though it doesn't necessarily come from that area, they used these white building materials because it's an ancient city, and in the days before air conditioning, this helped keep the city cooler than if they had used darker building materials. You'll see it in a lot of places, old places that are hot, like in Dubai. Most of the buildings in Dubai, pretty light color. And scientists are actually trying to develop the most reflective materials they can for use in cities, especially on roofs. And this is a cutting edge thing where they took some specialized white paint and it actually absorbed less heat from the sun than it emits. So a surface painted with this special type of white paint actually helps to cool the building. It passes out more energy than it takes in. That's a concept known as a cool roof. And that's anytime you use a fabric, a material, or a color on top of a building that's going to reflect more sunlight. Because we know that a building that reflects more sunlight is going to be cooler. So in an old city like here in Chicago, have traditional black tar roof, it's going to soak up a lot of sunlight. Whereas if you coat it with some either white paint or this new type of material, it's going to be a cool roof because it's going to reflect more sunlight. Here you can see here's a building that was coated in that new cool material, and it comes up pretty blue. It's a low temperature. Notice the black parking lot comes up very hot. On that note, asphalt parking lots are a lot hotter than concrete ones. So if you can use more concrete, you can help keep the temperatures of the city down. Dark pavement only reflects about 10% of solar energy, whereas cool pavement made out of the right materials and the right color can reflect about 40%. Well, that's a big difference in your resulting temperature. You can actually see it here. It's another experiment, a thermal image. Here's the traditional asphalt. Comes up a lot hotter than this new cool pavement. You can use less asphalt at all. If you don't use dark colored petroleum-based asphalt, if you have an option to use some other type of material, it can help keep the area cooler. Put plants anywhere you can. Here's an example of some green railways. Instead of having just regular rocks in between the tracks that get hot, plant some grass. Work in some plants any place where there's normally a lot of pavement. Like you see, putting even these little clumps of grass in the parking lot are going to soak up some sunlight a lot more than the asphalt would in terms of being used for photosynthesis and not raising temperature. Stick plants anywhere you can, any little nook and cranny, because then collectively, the more plants you have, the more sunlight you're going to soak up for photosynthesis, and the lower the temperatures are going to be. Now, in places like Florida, other places that get particularly hot, they typically will paint their whole buildings lighter, brighter colors so they want to reflect sunlight. We wouldn't see our houses here in Alpharetta, North Fulton, Atlanta painted these colors so we don't get that bright of sunlight like they do. But places near the equator, like here at Aruba, or Puerto Rico, or older, more ancient structures like in Greece and the Mediterranean, use very light colors or white even to help reflect sunlight, and that's going to help keep your town a cooler color. So now what you're going to do, across the top of your page, label a sheet, Final Temperatures Lecture, and you're going to list this vocabulary and identify the key concepts shown in these next two slides. This is what I'm holding you accountable for. Not a whole lot of new material, but here are the concepts. You need to understand and be able to answer these concepts at least in your head. Bring your notebook for a done stamp just for watching and summarizing this presentation, and then be prepared to take the notes check.